Okay, hello. In this screencast, we're going to solve this problem that is from an Introductory to Tensor Calculus textbook, Introduction to Tensor Calculus and Continuum Mechanics. We're asked to, it's a fairly simple problem, but it's going to show us how to use several functions in Mathematica, namely the sum table and the nested for loop. Okay, we're asked to show that the product of aik and ajk is equal to bij, where ij and k are indices that go from 1, 2, and 3. It's the same as the matrix representation of A times the transpose of A to equal B. Now, we see that aik and ajk is equal to bij. We note that I and j appear on both sides, so they are free indices, and k only appears on the left, so it is a dummy or a summation index. Now we know that there's going to be 9 equations because we have 2 free indices going from 1 to 3, and there should be 3 terms as shown here, because we're going to sum on k and there's only one summation index. Okay, let's open Mathematica. All right, clear all. And let's define A to equal, it's a table, subscript, lowercase a. The arguments of the subscript are I and j, that's a subscript function. And then we go I 1 to 3 and j 1, 2, 3. Of course, you can use any variables you like. And now let's have a look at this in matrix form. It's good to close the term in parentheses, because matrix form will actually change your variable a bit. Okay, that's A. If we want to look at the, say, first term of A, we use this. If we want to see, okay, I messed up here. It should be from here. Okay, that's exactly what I was talking about. So A11 gives us the first element, or the row in the, or the element in the first row in the first column. Let's take a look at what's in the first row, third column. As expected, we get A13. Okay, now let's define B. And we'll delete this. And we'll use capital B. And here we use lowercase b. So that's B, and no need for this. Okay. Now, like I said, we're going to look at the left-hand side, which is here, left-hand side, which is going to be all these terms. I'm going to call all these terms here the left-hand side. And I'm going to put them in a table. So there's a total of 9 equations and 3 terms in each. So the left-hand side will be a total of 27 terms. So now we need to use the table and sum function. The table function will have the argument, the free indices will be the argument of the table function, and the sum function will have the dummy index argument, or the k. So let's see how can we use the table and sum function in the same statement. So we will say table, open parentheses, sum, open another parentheses, and now we need to multiply, and I'm going to use the same notation used in the example above here, I, k, and j, k. So I, comma, k times, note that we're using the regular times because you are multiplying components, j, comma, k, and now we use a comma, and then we put in the argument for the sum, which is the k. Okay. Now we close the sum function and we use another comma, and now we use the argument for the table function. The argument for the table function are your free indices and not your dummy indices. So now we're going to use the free indices, which is I and j. And then we close again. Okay, let's see what happens. And as we expected, we get a total of 27 terms here. Here they are. And this is going to be, let's take a look at this in matrix form. Okay. So now we know that these are my terms. But we want to produce an answer that's going to be the same as what is shown here in the problem. So let's use a nested for loop and print out all the terms in the left-hand side, or what we call the left-hand side matrix, and set them equal to each corresponding term in the B matrix, which are these. So B is a 3 by 3 matrix, and your IJK, or your left-hand side, is also a 3 by 3 matrix, but each term is, or each element is made up of 3 terms. So we go back to our Mathematica here, and let's use a for loop. Okay, so my for loop before, now you can use any variable you like, it's just we like to use I, but note that this I is only in the for loop and has nothing to do with any of the previous i's we defined. Okay, that's the outer loop. Now we use another for loop inside, and you use j. Again, this j has nothing to do with the previous j we as discussed. Okay, now I'm within the nested for loop, and all I want to do is run the print function. So it's a print of what we call the left-hand side. Now you need to use 2 brackets when you are entering any matrix, and then we say I, comma j, and we will print the I, comma j. And we also want to print out an equal sign, so we put it between quotes, and then we want to print out what's on the right hand side, which is just simply my B matrix of I, comma j. Okay, so let's bring this closer. Yes. Okay, now let's close the print function, let's close the first for loop, and let's close the second for loop, and let's see what will happen now. So we don't want to see any of these terms anymore, so we put semicolons. Okay, something didn't work. The print function Why is the print function not working? Here I equals 1, I less than 4, I plus plus, and then j equals 1, j. Oh, I got these backwards. J less than 4, j plus plus. Okay, and now the print function should work. So here are my 9 equations. So as expected, we got 9 equations because there's 2 free indices going from 1 to 3. And 1, 2, 3, 4, 5, 6, 7, 8, 9. And now we can compare that with our answer shown in the problem, which is here. And that's correct. So now let's also show that the transpose of A times, or A times the transpose of A should get us the same result. So we do A times transpose. Here we use a dot because it is a matrix. We're multiplying a matrix and not element by element. And let's not show this. And let us show this. Okay, the print will show no matter what if you have here. But there is A times the transpose of A. And let's have a look at that in matrix form. Okay. And we note that those are the same. See, the first A11 squared, A12 squared, A13 squared is this term. So let's check A21, A22, A23 squared is the same as this. And we can check each of these one by one and we will note that they are all the same. For instance, this matches this, and so on and so on. Okay, and so that's how you use the nested for loop, the sum function, the table function, and also the print function in Mathematica. Okay, thank you.